Hey, how's it going? So we're going to continue with our oxidation reduction, super fun stuff. And we are now going to look at balancing oxidation reduction reactions using the half reaction method. Super fun. Seriously, I love it. So we are going to balance redox reactions using the half reaction method. Must you use it? Yes. Okay, balancing. Oops, let me share my screen here. And basically, we just got to jump into some example problems. Balancing redox using half reaction method. Okay, let's talk about what the rules are, guys. Hopefully the rules are in your notes. Do we need to write them down? No. Let's go look at them. Okay, so first of all, what you need to notice is how we do it is different in an acid than in a base. Why is it not showing what I highlight on there? That's weird. Oh, it's lagging. Okay, it's different in the acid than in the base. It can be seen here that the stoichiometry of the full redox equation is related to the changes of oxidation number. Okay, so this equation is different than what we're used to looking at. All right. Okay, this is going through what to do. All right, I am going to do it on my own because that's just the way we do these things here. Okay, so let's go. And I actually have some examples here. I'm going to go back to this worksheet here that we were looking at last time. Not that silly guy. I'm sorry, I'm wasting your time. Reactions packet. Let's look here. Balance the following redox reactions. In each case, give the balanced half reactions, identify, give the balanced net, identify agents. This is in an acidic solution. I hope this is easy. I haven't done this since last year. Let's identify our half reactions. This is going to be one, okay? And this here will be the other. Hopefully you could see why I picked those two. I just want my arrows to be a little bit neater. Hopefully you can see why I picked those two, because those two have elements that relate to each other, all right? So let's work with the first one. I've got Cl2 over to Cl negative. Oh, that negative should definitely go up top and not down on the bottom. Okay, I'm really not concerned about my phases right here. So if that's going to bother you, first step, balance anything other than, balance all elements. Balance all elements that are not hydrogen and oxygen. Students always forget to do this too. Okay, well, that's easy. I'll put a 2 here. Step 2, balance H and O with by adding water. Well, I don't have any H or O's, so I don't need to do that. Now I'm going to balance charges by adding electrons. Okay. All right. Well, what I see over here is I've got an overall 2 negative charge. Overall here I have a neutral charge. So if I add 2 electrons over here, I'll see that they're now balanced. Okay. So what I have here is one balanced half reaction. Okay. This shows the gaining of electrons. So this is my reduction reaction. Right? This is my reduction reaction. Therefore, Cl2 is the oxidizing agent. Okay, let's go ahead and write our second half reaction. Okay, so I'm going to need some more space. I can already tell. I'm going to start over in the center. S2O3 2 negative. And over here, I've got SO4 2 negative. So remember the steps. Balance all elements that are not hydrogen and oxygen. That means I need to balance my sulfurs. So I need to put a 2 here. Balance H and O by adding hydrogens, by adding waters. Okay, well, what I notice here is I have 3 O's, and over here I have 8 O's. Each water has 1 O. I need 5 more O's, so I will add 5 waters over here, and we now have 8 O's. So those are balanced, all right? However, my hydrogens are not balanced, so right here, I need to add another step. Balance oxygens by adding water. Just get rid of that. Balance oxygens by adding water. Balance hydrogens with H plus. Okay, I apologize for that. Let me get this out of the way. All right. So right here, I see I have 10 hydrogens. And over here, I have 0 hydrogens. So I'm going to add 10 hydrogen ions over here. All right. Okay. The next thing I'm going to do is my last step, which says balance charges by adding electrons. Now, I've figured out how to do this easily. This has a no charge. This has a 2 negative charge. I'm overall 2 negative. Here I have two negative particles. I have 10 positive particles. That's overall a 6 plus. So this side must have lost electrons to become more positive. It looks like I need to lose 8 electrons to get me a 2 negative over here. So I'm going to add 8 electrons right there. All right. So let me clean this up, and you're allowed to have questions, okay? But what we see is that the electrons are over here. Therefore, this substance lost electrons. It was oxidized, okay? And therefore, it was the reducing agent. All right? So what we have here are 2 balanced half reactions. But we're not done, because we need to now do this thing here, letter B, give the balanced net reaction. Well, it's real easy. We've done all the hard work, guys. But in order for us to balance this net reaction, I need the electrons gained to equal the electrons lost. So in my steps, I'm going to make sure electrons gained equal electrons lost. All right. And I can do that by taking everything in the first reaction and multiplying it by 4. So now let's rewrite that. I have 4 electrons. No, that's 8, because 4 times 2 is 8. I have 8 electrons, 4 chlorine molecules, and 8 chloride ions. I do not need to do anything down here. I will just rewrite this equation here. Now what am I going to do? Last step is I'm going to, right here, last step, combine half reactions, cancel like terms, and combine like terms. So if they're on opposite sides of the reaction, we cancel them. If they're on the same side of the reaction, we add them. So I'm going to go like this. I'm going to bring all of my reactants down. Right? 8 electrons plus 4 chlorine plus 5 water plus, I think that's thiosulfate yields. Let's put all of our products over there. All right, 8 chlorides plus 2 SO4, 2 negatives, plus 10 hydrogens, plus 8 electrons. Right, now we're going to cancel like terms. Your electrons should always cancel because electrons gained should equal electrons lost. I have no more like terms here. So my balanced redox reaction is what is left over. It should have a balance of elements and charges. That's typically how I check my work. I'll show you. So I'll know immediately if I've made a mistake because I'm going to look at my reactants here and I'm going to look at the overall charge and I see all I have is 1 particle with a 2 negative. I'm going to look at my products over here. I'm going to look at the overall charge. I see 2, that's 8 chloride ions. That's 8 negatives plus 2 negative particles. That's a 4 negative. That's 12 negative plus 10 positive, which is overall 2 negative. So those are equal. That makes me assume that I have done the correct work and in fact have not made a silly mistake, because as you can see, there's lots of room for mistakes. One of my favorite things to do is balance a good redox reaction. Okay. Should we do another one? We should. Man, but that's so pretty. Okay, let's go ahead and do this one here. Sorry, just looking around, seeing what's available for looking at. All right, let's look at the second one. And what you're going to see is that it is in a basic solution. All right, so I am going to attempt to copy this. All right, I'm going to copy it. I'm going to bring it down here and I'm going to paste it so that we can do it. Oh, no, don't do that. Y'all, it's going to take me forever to get that back. There we go. Okay, so let's look at this one. I'm going to move him up a little bit. So that's what we're going to focus on. Notice this time we are in a basic solution. So that's going to change one step. All right, so I'm actually going to write the steps down as we go. We're going to identify half reactions. Okay, so I'm going to take O3 to O2 and the Br to the BRO negative. And I'm going to write half reactions. Okay, so I've got O3. I'm not going to worry about, y'all need to scoot over because I might have to add things on the side. O3 to O2. And I'll go ahead, let's go ahead and work on that one. Balance elements other than oxygen and hydrogen. Okay, well, there are none, so I don't need to do that. Balance, let's see, charges. Nope, no, I'm sorry. God, I'm losing my mind. Balance oxygens by adding water, right? Balance O with waters. So over here, I have 2 O's. Over here, I have 3 O's. So I need a water over here so that I will also have 3 O's, okay? Each water gives me 1 O. And then remember, I'm going to balance H with H. So over here, I need 2 H's. Now, because this is basic, right? Because this is basic, this is the only reason we did not do this last time. This is the only difference because this is basic. Hold on. I don't want that big black thing there. Because this is basic, we will add equal amounts of OH to both sides. All right. What that means is because I added 2 hydrogens, I need to also add 2 hydroxides to both solutions. Let me get my pen. To both sides. Okay? Next, we will balance charges with electrons. That's it. There can be no more, no less steps. There can be less. Okay, over here I've got 2 negative particles and 2 positive particles. That makes neutral. Over here I have 2 negative particles. So I will balance that by adding 2 electrons over here. So since this reaction is gaining electrons, gain electrons, this is my reduction half reaction. Okay, this is my reduction half reaction. I'm going to get this out of my way. Shoot. Shoot. Trying to, if I can. Oh, shoot, I just had it. Nope. Okay. Sorry, this is my reduction half reaction. Gosh. Sorry, this is my reduction half reaction right here. Okay. Now I need to get my other half reaction. I'm actually going to do that right here. I'm going to have Br negative, scoot them over because I have to get it on both sides. Br negative to BrO negative. All right, BRs are balanced, check. Balance oxygens by adding water, check. Balance hydrogens and the water by adding hydrogen ions. If it's basic, go ahead and add the same amount of hydroxides to both sides. Balance charges, 2 negatives and 1 negative makes 3 negative. Over here I have a 3 negative and 2 positive makes 1 negative. So over here I need 2 electrons. So I'm now balanced. And I have my second half reaction, which is the loss of electrons. This is my oxidation half reaction. All right. Now remember what we do is we combine the two and combine like species and cancel species. So we got a couple things to learn here. All right. I'm going to clean my board up because as you see, there's this problem creeping up on me down there that I can't get out of my way. let's go ahead and put our, don't use that color. Let's put our reactants together, and then we'll put our products together. And I'm going to do that right here. I'm going to write 2OH negative plus H2O. I hope we're on the right track and didn't make a mistake, guys. Don't forget those 2 electrons right there. 2 electrons. Remember, electrons are equal this time, so we didn't have to multiply. Now look here. I've got 2 hydroxides and 2 hydrogens. Well, those are going to combine to make 2 waters. Remember, hydroxide is like the strongest base there is. If there is a hydrogen floating around him, a hydrogen ion, he's going to take it, right? Bases take protons. He's the strongest base. He's going to take that guy. So I might as well just go ahead and write 2 waters here. Okay. And don't forget the oxygen there, right? He's kind of, I left him out. So that's a plus the O3. Let's go ahead and get our products in here. Highlight them. I often, it's easy to leave something out. We're going to have the BRO negative. The 2H and the 2, once again, hydroxides will make 2 waters. We've got 2 electrons, which is good. Down on the bottom, we've got an O2, we've got an H2O, we've got 2 hydroxides. Woo! All right, I'm going to clean my screen up here. Let's just finish this guy by simplifying and then checking. And I have to tell you, I'm a little nervous. All right, notice here I've got 2 hydroxides. Let me change that color. Let's do a green. I've got 2 hydroxides, and over here I have 2 hydroxides. So those will cancel. Over here I have 1 water. Over here I have 1 water. Those will cancel. I have 2 electrons and 2 electrons. Those are going to cancel. Oh my gosh, 2 waters and 2 more waters. Those cancel. So I'm left with Br negative plus O3 yields BRO negative plus O2. Well, that's exactly what I started with. But we still did it. We still know who was oxidized, who was reduced, how many electrons were transferred, who was the oxidizing agent, who was the reduction agent. We did a whole lot of work to realize that it was already balanced. But that's okay. We did it right. Can we check it? Yeah, we had a -1 and a -1. That was very anticlimactic, wasn't it? But hopefully you see the process. There was one more there, which was a disproportionation reaction, which is right here. And I'm kind of nervous to even try it because I often look at them before I, disproportionation reactions are not my favorite. But goodness, guys, can I cut this? I don't need to talk on the phone right now. A little bit busy. Okay, I'm just going to end, for your sakes, go ahead and end it there. Please bring your questions to class. Thank you. And you should go to the notes and do some practice problems in your notes, page 20, task 4.12, number 3. I think I have that right.